What? Class is almost over. Is that what you said? Do I look like I care? Let me think about that. Don't care. Don't care what you say. Did I post this? Yeah, I already posted this one. You like the grid system better? No. Holy mackerel. Okay, let's go over two-dimensional momentum.
Mr. C.
I'm going to go over the problems in your workbook. So you can turn to page 224. I'm going to go over that. Just read over the example problem, page 224. It's a difficult one. Mr. C4. What? Lowercase. All one word. Or all one. Mr. C4. No, everyone else is joined, so. No space. Look. There we go. Okay, you got it? Okay, that's probably why. Two-dimensional momentum. It's 224. That better for you? Okay, whatever. That's it. Okay, so just read it over carefully. I'll go over that one. Yeah. 224. Okay, so notice this problem here involves collision at 90 degrees. You've got a southerly moving object colliding with an easterly moving object. That's where the 90 degrees comes from. So it's a collision problem. So this should come to mind. Anytime there's a collision, you write out as many terms as there are objects. In this case, there's only two objects. So P1 plus P2. So usually up to now, we've been dealing with objects that move parallel to each other, usually side to side. So an object might be moving east, represent that by a vector pointed to the right. And then maybe the second object moves in the opposite direction towards the west. So what does that equal to? I'm just drawing what I just said in words visually with the arrows. What does that add up to? We would say it adds up to give some resultant, okay, in this case. Now, the reason why we were to line these up, the reason why we're able to use positive and negative signs is because these vectors are parallel. These two would reduce to 1. Thanks. Some resultant. This is your PR here. This is your P1. This is your P2. Now, again, why am I drawing this? Because I want to indicate to you why we can use simple math. If this is, in this case, let's say this is 10 kilograms meters per second. That's the unit for momentum. And this is 5. I'll skip the unit. And PR is 5. How did I get that? Just 10 minus 5. Kilograms meters per second. Okay, simple subtraction. Okay, why is that? Because the vectors are parallel. That's why we can use the simple math. So with the following problem, the vectors are no longer parallel, they're perpendicular. So this does not work. The math is no longer simple subtraction. So let's draw the diagram for this example. We've got, first of all, vector. Rewrite the equation so you know what I'm referring to. This still holds true. It holds true in terms of adding arrows or vectors. So what's the first vector? The first one that's mentioned is moving south. So you draw it downwards. Okay. So what is that first object? What is P1? P1 is just, in terms of magnitude, it's just equal to 4 times 2.8. Which is a little bit less than 12. Yeah, 11.2. Okay, so that's my 11.2. Plus what? Plus my P2. It mentions that the second object is traveling east. That's my P2 there. What's the value of P2? P2 is just the 6 times 3. That's your 18 there. What's it equal to? Well, it's not simply an addition or subtraction because they're not parallel. How do we find what this resultant is? That's the question. Okay. Well, let's reread the problem. It says here, actually, just scoot to the last sentence. It says, the objects stick together. Right there, Mr. C4. Okay. So let's rewrite this. Let's simplify it. How so? Well, I just said they stuck together. So these two are going to reduce to one term. They stick together, one term. So when we redraw this, actually I'll circle this, copy that. When we redraw it on the right, or when we draw it on the right, we have to indicate some sort of resultant. Resultant, I'm going to draw with the red arrow. I'm not sure which direction. I suspect it's probably going to look something like this. How do we find it? We take these two, we're going to add them up. How do we add them up? Tip to tail. You know what? I just copied. I'm just duplicating them. Okay, now move them in, obviously, so they're tip to tail. That's what I mean by adding them. Now, where's the resultant? The resultant is drawn from the tail of the first to the tip of the last. That is my P prime. How do you find it? Well, the math is now different because the white arrows are no longer parallel. So what math would you use to, in this case, this arrow here is 18, right? Put it down here. That's 18. And a perpendicular. What's the math that you'd use to find the hypotenuse? Yeah, good. So it's not as simple 11.2 plus 18. This is wrong. That's wrong. What's right? You just mentioned it. Pythagorean theorem. So 11.2 squared plus 18 squared is equal to what? P prime? No, P prime squared. Okay? Because they're not parallel, different math. Let's keep that in mind. Okay, so what's P prime work out to be? So P prime works out to be 21.2. Okay, the question is, what is the velocity? Okay, let's be clear. When they use the word velocity, they mean it implies magnitude plus direction. What do I mean by direction? I need to figure out, let's see here, which one do they use? Need to figure out what this angle is here. I'm going to use that. That angle there. Okay, so we need to find both what the V is in terms of magnitude and the angle. How do you find V? V prime is just equal to P prime. Divided by what? Well, they stick together, so it's the total. One and two stick together. Okay, so take this, divide it by the total mass. 4 plus 6, 10. I would round it 2 sig figs, it's fine. Meters per second. Don't forget. Now, you're not done. As I said earlier, you got to find what this angle is as well. So the angle, going back to the diagram here. Everyone got this? Is that clear? I'm going to go back to the diagram. What would you use to find theta? There's your hint. Tan of theta is equal to 18 over 11.2. Ooh. What's the angle? -90 minus 30. About 58. What'd you get? Here, I'll do it again. I'll do it this way. Yeah, so 58 degrees. How would you describe it? Look at the diagram. Pointed this way, right? Easy for me to show you on the board. I can do some. And you're defining it with respect to this green direction. Then it's tilted towards the east. Okay. So it's east of what? It's tilted to the east. East of, which way is this point? South. Okay. So east of south. Yeah. You see the difference now. It's no longer simple math again because the vectors are not parallel, they're perpendicular. Why they're perpendicular? Because it mentions that they're north and, excuse me, south and east with respect to each other. That make sense? So you've got to carefully read the problem. If there's any mention of the vectors being either perpendicular or some other angle so that they're not parallel, it's a different math. Okay, let's take a look at the example problem, page 225. This is a little more complicated. This is not a 90-degree angle. This involves something, looks like it's a little bit less than 90 degrees, but. So example 2. Oh, yeah. Yep, it's page 225. Let's read that. See if you can draw it. See if you can figure out, I mean, I would draw it in pencil because we're going to probably make some corrections, but see if you can draw the collision, what's happening before, what's happening after. I didn't get any sleep last night. I don't know. Could have been because I didn't have much. Some espresso before. That doesn't make sense. But it's just an espresso. It usually doesn't bother me. It's a coffee, definitely. Okay. So let's draw this out. First of all, it's a collision, so you know this. This equation must hold. Okay? But if we draw it, you'll see automatically it does not involve a 90-degree angle. It's actually less. It's 32 plus 41, so 73 degrees. So let's put a line down the middle representing the left side is before collision and the right side represents after collision. So what do we know for certain? Well, if you scoot ahead in the problem, it says the 4 kilogram, the first object moves after the collision at 2.8 meters per second at an angle of 32 degrees north of east. So this would be your, I want to draw it in white. This would be your P1. Okay, so what is your P1? Your P1 in magnitude, P1 is mass times velocity, or 4. And this is going to be prime, right? After the collision, prime. Yeah. So 4 times 2.8. So that works out to be 11.2. Okay. And that is at an angle of 32 degrees north of east. So yes, it's pointed up. Okay, what about the second object? Well, we're told it bounces off at 41 degrees. That's my P2 prime. What's it equal to? The magnitude, mass times velocity. So it's 6.1 times a 1.5. And that works out to be 9.15. You carry an extra digit, and then round to 2 at the end. Okay? At an angle of, like I said, 41. Okay? Now, backtracking to the very beginning, it says, the beginning, the first sentence, a 4-kilogram object headed east. This is going to be a resultant. You'll see why in a second. But it says it's headed east. I actually made a mistake. It's actually, we're going to find out it's slightly south of east. So I'll draw it slightly at an angle. That is your initial momentum, P1. What about P2? P2 is 0. It says here that the second object's at rest, so that is 0. It's not moving. All you have is one turn on the left, P1. Okay, now let's line these up. Line them up as how? Well, the white arrow should add tip to tail. That's what this says. When it says plus, it means add them tip to tail. Add P1 and P2 prime tip to tail. Okay. To make this actually work out, I'm going to redraw it so it looks a little bit more. What it should look like. 32 degrees is actually lesser of an angle than I drew it. That's more like 32 degrees. Okay. And I'm going to put in numbers. That's my P1 prime. That's, I'm going to replace it with a number. So that's 11.2. That's my P1 prime. What about my P2 prime? My P2 prime is here. Going to look something like that. That's my P2 prime. I'm going to erase it in a second. Just put in the number. That'll help me out. Simplify. So that is what I calculated here. 9.15. What are they going to add up to give? They're going to add up to give this here. So the resultant is the red arrow. It's drawn from the tail of the first to the tip of the last. That's my P1. So the math is not, it's not simply 11.2 plus 9.15. It's not that equal to P1. That's wrong. Why? Because these are not parallel. These form a triangle. So different math, and it's not even a right angle. This is not a right angle there. Okay, you could show that if you want, but it's not. Trust me on that. So I'm going to redraw it. Make it a little bigger. Duplicate it here. I like making it bigger. I need it bigger. Okay. So why did I make it bigger? Well, I'm going to have to draw the components in.
No.
Let me just make this smaller. And this smaller. Okay. Okay. So I'm going to use yellow for the X components. With that X component, that X component. Okay. What's the angles? The angle here is 32. No, that's not 32. Is that 32? Yes, that's 32. The angle here is given. That's 41. Okay. Now, let's figure out what those corresponding X components are. I want you to try that out, see what they are. What are the X components? The yellow components. Given the hypotenuse, given the angle. This is not 32 here, by the way. So I got to remove that. That's going to cause confusion. What's the X components? So this one here is 9.15 hypotenuse times the cosine. I'm going to erase this because I've got to, it just gets too messy. So 9.1 times cosine of 41 is 6.91. That's the X component of my P2 prime. What about this component here? 11.2 times the cosine of what? 42. Sorry, 32. 32. Which is 9.5. I'm going to erase it. It's getting too messy, so. Okay, so why did I do that? Because you can show the following, that these two yellow X components are equal to the X component of this resultant. That is P1X. And they're all parallel. They're all parallel. So mathematically, if vectors are parallel, you can simply add or subtract, depending upon whether they're in the same direction or not. You have 9.5. This one plus this one is equal to what? This P1X. This should be an X here. Seven plus 9, 16 and a half. 16.4. Okay. Now I'm going to use purple for my x, or sorry, y components. Is that clear? No, that's not really clear. Is green better? Yeah, I'll use green for my y components. I've got a y component in this direction. I've got a y component for my P2 prime in this direction. Figure out what those values are. They're opposite the angles. Find the values of those. They're opposite directions. So one's positive, one's negative. So on the left here, you have 9.5 times the sine. On the right here, you have, sorry, I'm falling asleep here. This should be the hypotenuse, 11.2. On the right, it's 9.15 times the sine of 41. Okay, so what are those values? And it's negative. Negative. $11.2 times the sine of 32 is about what? 5.5-ish? $5.9. I'm going to erase it. I need the room. So this here is 5.94. On the right side, this is -6. Yes, I know there's units, but we'll leave those off. So these two sides are not equal. One's -6, the other one's a little bit shorter, 5.94. Those two add up to give the y components here. P1y. Such that what? 5.94 minus the 6 is equal to P1y, which is equal to 0.06 negative. And what do those green and yellow components make up in terms of an angle? Oh, that's bad. They make up a right angle. They make up a right angle. So what kind of math can you use to figure out P1? P1 is here. This is P1. It's a hypotenuse. What's P1 equal to? P1 squared is equal to this side squared plus this side squared. You agree? So 16.4 squared plus, just use the magnitude, 0.06. Yeah, don't need that, squared. So P1 works out to be 16.4. There's not much, this doesn't add much, so it's still 16.4 kilograms meters per second. Are you finished? No, because there's an angle here. There's an angle here. It's the same, you'd actually use this angle here. It's the same, those two angles are the same. Okay, how'd you find that angle? It is the tan. Is equal to P1y over P1x. P1y is 0.06. Don't worry about the negative. Use the magnitudes only. It's a very small angle, so it's 0.21 degrees. And where is it actually? It's this angle here, which means it's south of east. We'll go over more examples. Kind of tough. What are you doing essentially? You're essentially doing this. If this helps. You're taking this equation you're simplifying it. We said earlier that this is 0. Reducing it to that. And then you're breaking it up into x and y components. You're saying this is actually just a short way of writing this. P1x is equal to P1 prime x plus P2 prime x. And there's two equations. So this is actually hiding two equations. Same as the one above, except everything's a y. That's all you're saying. Yeah. Yeah. Okay, I'm not done because I'm going to show you visually what these two equations mean. What did these mean? Well, let's break, you know what? I need it broken up individual. Whoops. Okay. I need that one down here. What do these mean? Visually, it's just what I said earlier. This one here, this first equation is that's your resultant. What's it equal to? This vector plus this vector. What about your second equation? That refers to the green arrows here. Well, one arrow pointed up. Oh, sorry. Green arrows here. Plus that pointed down. What's that equal to? A small vector pointed down. These two will add tip to tail to give you that. That's your resultant. What does it say above here? These two yellow arrows add tip to tail to give you this, the resultant. We'll do more. But that's essentially what you're doing. You're turning this one equation, into two. One for the x, one for the y. Now, why didn't you just use the Pythagorean right away? Because when we started, this is not a 90-degree angle. This is not a 90-degree angle. So you can't use the Pythagorean theorem. Until what? Until you break them up into the two equations, which is what I did. Okay? Once you've broken these up into the two equations, then you end up with what I showed you. You end up with a P1 x, and you end up with a P2. Sorry, P1 y. Now you can use the Pythagorean theorem at the very end, because these two vectors are perpendicular. That will give you what I've been calling P1. Whoa. my P1. There's a lot there. So we'll go over more. For homework, try Try 1 to 3 on page 228. These are just the first type. These are all right angles, similar to the first example. If you want to try 4 and, well, if you want to go on to 4 and 5, we're going to get to those, so feel free to do that. But I'm going to go over 1 to 3 next day. I will give you extra practice with the non-90, especially the non-90 degree angle. And the last one we just went over. That's hard. Okay? So that's it. Did I give you your test back yet?